Hello, my name is Las Korinkapov, and I am a professor at the Faculty of Electrical Engineering and Computing at the University of Zagreb in Croatia. The aim of this presentation is to give a brief overview of the main goals, objectives, and methods related to the project Modeling and Monitoring QE for Immersive 5G-enabled multimedia services. This project is funded by the Croatian Science Foundation. The project is ongoing and lasting from January 2020 to January 2024. The project brings together a multidisciplinary team, so we have team members coming from various faculties at the University of Zagreb, so the Faculty of Electrical Engineering and Computing, the Faculty of Graphic Arts, the Faculty of Humanities and Social Sciences. Also, we have a team member from Ericsson Nikola Tesla, and also an external member from the Faculty of Traffic and Communications in Sarajevo in Bosnia and Herzegovina. So here we list some basic facts about the project. The acronym is Q-MERSIVE. As I said, the project is funded by the Croatian Science Foundation. And for any updates or further details regarding the project, please refer to the website which is listed on this slide. So as I mentioned, the Q-MERSIVE project brings together a multidisciplinary team, combining complementary expertise from engineering and networking, psychology from the Faculty of Humanities and Social Sciences, and also interface system design and usability coming from the Faculty of Graphic Arts. Here listed on this slide are our team members. So we have a range of both early stage researchers and also senior researchers. And in addition to team members, also bachelor level and master level students supervised by professors in the project team or also will contribute to project activities in the scope of their bachelor and master thesis work. With respect to the project motivation, we know that rapid developments in the telecommunications and network communities, which are centered around cloud-based infrastructures and the migration towards 5G architectures, are paving the way towards new service delivery opportunities, including in that context also advanced immersive services such as networked augmented virtual reality, cloud gaming, 360-degree VR streaming, various tactile applications, and so on. What we also see is that applications leveraging technologies such as AR and VR will likely go beyond early adopters that we see nowadays, such as gaming, to also enhancing social experiences, to being used in healthcare applications, education, various industrial use cases, and so on. This will, of course, also lead to complex user behavior models, reflecting also new service usage patterns and also network traffic characteristics. In the context of new and emerging networked applications such as immersive AR and VR, assessing and modeling the end user quality of experience remains an open research challenge. So given the complexity of such services, the availability of new hardware appearing on the market and new application domains, we see that the research community is faced with the challenge of exploring new methodologies, models, and metrics to understand and measure the end user experience. Due to strict latency and bandwidth requirements, the underlying network and cloud system performance obviously play a critical role in meeting these end user requirements. And further, also a high degree of interactivity implies the need to consider also user behavior and interactions as factors contributing to QoE. So this is brings together the motivation behind this project and what is actually motivating us to consider now these new QoE methods, models, and metrics in the context of new and emerging immersive services. So on this slide, we just illustrate the basic steps involved in developing solutions for monitoring and managing quality of experience, going from initial user studies organized to collect actual subjective feedback from end users with respect to various test conditions, using information collected during user studies, both in terms of subjective and objective metrics, to develop QE models, which then model the relationship between various influence factors such as human, system, or context influence factors and QE or various QE dimensions. Using these models, determining which factors need to be monitored, either in the network, at the end system, or so on, in order to monitor QE at various timescales, and then, of course, using this information to actually provide solutions for optimizing and controlling QE in terms of QE management. So these are the basic steps involved in this process. So in terms of project goals, we specify two main goals. The first would be to propose novel QE models for, on the one hand, immersive 5G-enabled networked AR and VR applications. And our second focus would be on mobile multi-party conversational video communication services, which we see are becoming more and more prominent nowadays. So the idea of these models would be to specify this mapping between underlying system context and human factors to QE as perceived at the user level. On the other hand, the focus would be on utilizing these models for developing in-network monitoring solutions. So we're looking at developing novel solutions for in-network monitoring of QoE and various key performance indicators, which actually represent dimensions or application level factors which impact QoE, using as a basis these developed QE models. So along with any other relevant state-of-the-art models that already exist in either literature or standards, or that will emerge over the course of the project. With respect to methods, we will look to utilize various machine learning-based techniques or various analytical approaches. The actual research areas are split into three main areas, which are listed here. So research area 1 will focus on the QE assessment and modeling for immersive VR and AR. Research area 2 will focus on QE assessment and modeling for mobile multi-party video communications, whereas research area 3 will focus on in-network QE monitoring, applying machine learning techniques. So in the rest of this presentation, I'll just briefly go through the main objectives and methods related to each of these research areas. So in the context of research area 1, where we are looking at immersive VR and AR, if we first of all refer to the recently published QualiNet white paper on definitions of immersive media experiences, immersion there is identified as referring to the degree to which immersive media environments submerges the perceptual system of the user in computer-generated stimuli. So briefly, if we are talking about AR, the main goal would be to create a highly realistic experience of interacting with virtual elements in a real-world setting. Or on the other hand, if we're talking about virtual reality, to create a sense of inhabiting a world that is completely artificial. As such, actually, VR and AR applications are expected to transform the way people interact with each other and also with various computer and software systems. Networked AR and VR are among important use cases which have been identified for upcoming 5G networks. Now, going back to the user perspective, we know that to successfully manage quality of experience, it is necessary to understand and identify multiple factors affecting the user QE. What we see missing today are still QE models and frameworks for various immersive media scenarios which are emerging. A lot of recent research has been targeted in this direction, also various work in the scope of standardization organizations. However, there is still a lot of open research issues in this domain, in particular also taking into account, for example, user and context factors. So we're looking at some kind of models which then would effectively in the end drive some kind of QE management mechanisms. Since both AR and VR are interactive multimedia services, which promise these unprecedented levels of immersion and ways of presenting virtual worlds, it is important for them to provide a comfortable and positive experience for end users. So this is a key thing in order to achieve widespread adoption. As both of these technologies have yet to reach mainstream acceptance, significant effort has to be invested towards understanding and optimizing this end user experience. So following these challenges in the scope of the project, we will aim to develop novel QE models for such applications that will rely on empirical user studies involving both objective and subjective data analysis. So with respect to the methodology, the project plans to employ an iterative approach where user studies will be conducted in phases. So 4 VR study phases spanning project years 1 through 4 and 3 AR phases spanning project years 2 to 4. With the idea being to gradually refine the selection of influence factors and enhance model performance. So certain research goals will be addressed in each phase, and then analyzed results will serve as input for subsequent studies, which will then be planned. In addition to subjective measures related to user perception or psychological state, where relevant, we will also collect various subjective measures, including behavioral and psychophysiological measures. So we know that psychophysiological measurements may, for example, be used to explain QE assessment of subjects and improve existing QE models. Furthermore, also understanding users in terms of their task or goal when using a certain service can act as an additional source of information. Behavioral data using information on user interactions, for example, mouse movement, gestures, eye tracking, can also provide further input for the modeling process. In terms of the actual applications and prototypes that we will use, we will rely on both existing VR/AR applications and also prototypes which we will develop in particular for the project. Our focus will be on primarily on interactive media. So with respect to VR, initially we'll focus on entertainment and gaming, while subsequent then study phases will extend to additional domains, in particular to various networked scenarios, multi-user scenarios, and so on. With respect to AR studies, potential application domains that we will look at will include education, remote collaboration, and also some industrial use cases, building also on previous work and our expertise from previous projects. So moving now on to the second research area focused on QE assessments and modeling for mobile multi-party video communications. We know that despite the availability nowadays of numerous applications that offer audiovisual communication services, strict low latency, high volume requirements continue to impose challenges in meeting end user QE demands, especially in the mobile context. When looking at video communication services, a key challenge faced by service providers lies in configuring the video encoding parameters so as to maximize participant QoE while meeting availability of resources, so constraints with regards to, for example, network, mobile devices, and so on. So multi-party video call optimization is a challenging task due to dynamic wireless networks, heterogeneous mobile devices, and various contexts of use. And there are to date limited studies that focus on modeling and optimizing QoE in a mobile multi-party context. So in our previous work, we have conducted a series of user studies to assess QoE for mobile multi-party audiovisual calls under various video encoding and network conditions. So we have looked at how to adapt parameters such as the resolution, frame rate, and bit rate so as to optimize end user QoE under various network and system constraints. Now, while these studies have provided valuable insights into the impact of various video quality levels on user perceived quality, what is still missing are service adaptation strategies to drive these video encoding configuration parameters, building on already existing work. So the Q-MERSIVE project will thus build on these previous results and aim to propose QE-driven service adaptation strategies under variable resource availability. Moreover, additional user studies will be conducted to investigate the impact of different contextual parameters and also to validate QE modeling results. So this will briefly be our focus in terms of mobile multi-party video communications. As I said, our focus will be on at least 3-party video calls and on how to optimize these video encoding parameters so as to achieve the highest QoE while efficiently using available both network and system resources. So we will build on the user studies which we have conducted to assess QE, establish in a private and leisure context with limited end user device screen size and low to medium motion content. In the scope of Q-MERSIVE, our aim will be to build on these results by performing extensive analysis of both subjective results, objective video quality metrics, and also WebRTC internals data collected during user studies. So the goal will be to develop a QE model for multi-party audiovisual telemeetings on mobile devices, quantifying the relationship between objective and subjective quality metrics. The QE model will then, as I mentioned, serve as input to specifying a QE-driven video encoding adaptation strategy, for example, dynamic adaptation of bitrate, frame rate, and resolution, then to be applied in light of variable network and system resource availability. So these are, again, the main methods that will be employed in this area. And finally, research area 3 will be focused on QE monitoring aspects, and in particular on in-network QE monitoring, applying machine learning techniques. So for application and service providers, we know that it is of crucial importance to be able to monitor service quality, identify root causes of perceived impairments so as to provide the basis for potential problem mitigation and also QE control and optimization, for example, dynamic service adaptation, dynamic resource allocation, and so on. In order to put QE models to use, so develop QE models in order to utilize them, this requires the collection of necessary input parameters for various types of services in order to deploy monitoring architectures. Monitoring architectures commonly collect data using passive or active probes deployed along various parts of the service delivery chain. So data may be collected at different levels, including network level QS measurements, traffic characteristics, as well as also at the application level, such as, for example, in the context of video, buffer status, audio-video bit rates, resolution, startup delays, and so on. This information then needs to be fed to application-specific QoS to QE models so as to obtain insights into estimated QE. Now, while we know that client and server-side logs provide access to relevant application-level metrics which are needed to estimate QoE, for the most part, if we look at the network perspective, for the most part, network providers do not have access to probes on the client device or the application server, especially in the context of over-the-top applications. So consequently, network providers primarily rely on traffic monitoring solutions that are deployed within their network for estimating QoE and performing some kind of root cause analysis of potential quality impairments. Arguably, the largest impact on the growth of network traffic has to date been attributed to popular OTT video streaming services, which is why one of our initial focuses was in this area. However, due to security and privacy concerns, most OTT streaming services have introduced nowadays traffic encryption, which has led to previously used deep packet inspection methods becoming obsolete for QE monitoring purposes from a network provider perspective. So aiming to address this challenge of in-network QE and KPI estimation for encrypted video traffic, machine learning techniques have been recognized as a promising way forward. So we have already addressed some of the research challenges in this area through previous projects and demonstrated the potential of applying machine learning in this domain, whereas our main focus up to now has primarily been on adaptive video streaming such as YouTube. We have also conducted some initial studies to investigate the application of machine learning techniques in monitoring WebRTC-based audiovisual communication services. However, and then this is what we see on this slide. So we see various the steps involved in conducting these studies, going from instrumenting the tools for collecting ground truth data to developing QE models or modeling the relationship between network data and QE metrics, to deploying QE monitoring solutions and performing then some kind of or generating some kind of reports, alert generations, performing root cause analysis, and also reevaluating the system and automating the whole process. This is what we see here on this slide. However, while extensive efforts are currently being put into tackling this challenge, a number of open issues still remain, including questions related to data collection instrumentation, availability of data across different services, which modeling techniques to use, online detection of changes in service behavior, and consequentially triggering of automated model adaptation. So while a lot of efforts have been put into applying these methodologies to adaptive video streaming, an important issue is also extending these approaches to other application domains as well. So when we talk about extending these efforts to other domains, this could encompass domains such as conversational video, 360-degree video gaming, AR, VR, various types of advanced web services, cloud-based services, and so on. The widespread use of traffic encryption, so coupled with complex relationships between measurable network-level performance parameters and QE-related application layer KPIs, opens this potential for utilizing various machine learning techniques for QE monitoring purposes. So the objectives that we look at are listed on this slide. So investigate the relationship between network traffic and QE for services that go beyond traditional video streaming, and to develop models to estimate QE based on network traffic collected using probes. Another issue is that while multiple players are involved in this service delivery, questions remain as to who has access to which data. In light of certain context, content, or user-related data exposed to the network provider, for example, via APIs provided by the application provider, opportunities would open up also for network providers to make more informed and personalized QE estimations. So we will also look at potential solutions in this area, and also focus on model generalization and, as I said, extension to other application domains. With respect to methodology, briefly, the plan is to build on previous research results by first proposing a generic framework for training of machine learning models for estimating QE and application level KPIs to start off with adaptive video streaming services based on the analysis of encrypted network traffic. The methodology will be evaluated using various data sets collected in both lab and mobile environments. To address the potential for commercial deployment of such solutions, so we will also focus on investigating methods for generalization of models. Further steps will focus on identifying how to modify the framework to other domains, as I already mentioned. So, for example, to multi-party video communications, gaming, AR, VR, and so on. Also, given the fact that this in-network QE monitoring is further complicated in light of realistic end-user interactions which are performed during application usage, we will also investigate various usage behavior patterns and their implications for QE monitoring. So we will look at the impact of this user behavior aspects on the QE monitoring and management cycle. Finally, the overall monitoring framework will be mapped to a concrete 5G architecture, and the potential for performing some kind of root cause analysis will be explored. So this was a brief overview of the main goals and research areas that are being addressed in the scope of the Q-MERSIVE project funded by the Croatian Science Foundation. For further details, please refer to the project website, and also please feel free to contact me if you have any further questions.